How do you use thermodynamic property tables with varying formats? Imagine trying to solve a puzzle but each piece looks different. That's what working with thermodynamic property tables can feel like at first. These tables hold vital data about substances like water and steam, but they come in many formats. Knowing how to read each one makes solving thermodynamics problems much easier. First, recognize the main types of tables. Saturated steam tables are common. They show data based on pressure or temperature. If you know the pressure at which water boils, you can find the temperature and other properties in the pressure-based table. Conversely, if you know the temperature, use the temperature-based table. These tables list properties for both the liquid water and the steam that forms when water boils. You'll see columns for pressure, temperature, specific volume, enthalpy, and entropy. Superheated steam tables are different. They list properties for steam at temperatures above the boiling point for a given pressure. These tables are organized by pressure, with rows for different temperatures. Here, you can find specific volume, internal energy, enthalpy, and entropy at various temperatures for each pressure. Subcooled or compressed liquid tables are similar but focus on liquids below their boiling point at a specific pressure. When data isn't available, you can estimate properties of compressed liquids using saturated liquid data at the same temperature. Using these tables effectively starts with identifying the state of your substance. Is it saturated, superheated, or subcooled? This helps you pick the right table. Next, determine what you already know, pressure or temperature. If you know the pressure, look in the pressure-based saturated or superheated tables. If you know the temperature, find the temperature-based tables. Once you've chosen the right table, locate the closest value to your known property. If your exact value isn't listed, don't worry. You can interpolate between the two nearest entries. Interpolation involves drawing a straight line between the two closest data points and estimating your property at the exact value you need. After finding the correct row, read off the properties you need. For saturated tables, properties for both the liquid and vapor phases are available. Pay attention to units. Pressure might be in pounds per square inch or megapascals, and temperature could be in degrees Celsius or Fahrenheit. Symbols like P for pressure, T for temperature, V for specific volume, H for enthalpy, U for internal energy, and S for entropy are standard. Saturated liquid properties are often marked with a subscript F, vapor properties with G, and differences with FG. When data is limited, especially for compressed liquids, using saturated liquid data at the same temperature provides a rough estimate. Keep in mind this introduces some error but often works well for practical purposes. Engineers use these tables to calculate energy changes in steam power plants, refrigeration cycles, and heating systems. For example, knowing the enthalpy change during steam expansion helps determine how much energy is transferred. This information is essential for designing efficient systems. In summary, working with varying formats of thermodynamic property tables involves first understanding the type of table you need. Then, identify your known property, locate the closest data point, interpolate if necessary, and read the required properties carefully. This approach turns complex data into practical information you can use to solve real-world thermodynamics problems.